Cool guys, so today we're gonna discuss the Codeton round 4 that was rated for Dev 1 and Dev 2. So we'll be discussing the first 4 problems. The first 3 problems I'll be discussing in detail. I'll also be discussing the problem 4 in detail, but I actually have copied the code for problem 4 from the editorial section itself. So yeah, for the rest of the problems, the code is authentic or it's mine. For problem D, the code isn't mine. So cool, let's discuss the problem A. Problem A is beautiful sequence. It states that the sequence of m integers a1, a2 up to so on to an is good if and only if there exists at least one I such that ai is equal to ai. Now what does this mean? So basically that means is that you are given a sequence. So this is the entire sequence you have, right? Now what they're saying is that select any sequence, subsequence. Now subsequence basically means that you can delete any number of elements from it, but you still should have at least one element left in it, right? So after deleting all of those, if the element is having the same value as the index, then you'll consider it to be valid. So this was pretty straightforward. I'll say nothing much needed to be done. You could have simply said that if your current element, if that particular element has a value that is less than or equal to its index, in that case you can say that I'll delete some of the elements to its left. That could be like I'll delete 0 or I'll delete more elements to its left to make its value equal to its index, right? So this was pretty straightforward. Just I think a 5 line of code, because the rest is the standard code I have. So yeah, just 4 or 5 lines of code for this. And to be honest, very easy problem. We don't generally expect such easy problems from Codeforces. So let's move to the problem B. The problem B is this. This problem is about candy. Initially, you have one candy, and you want to have exactly n candies. So I'll not be going through the gibberish, but there are two kind of operations you can perform. That is, you can make a number 2x minus 1, or you can make that number 2x plus 1, right? After performing these operations some number of times, you want to have a value exactly n. If you're able to do it, then you have to print the moves that is required. So this is the operation 1, this is the operation 2. So if you're able to do it, then you print out the moves that are required. If you're not able to do it, then you have to say minus 1. Now this relies on a simple observation. Let me discuss the observation itself. Okay, so what I'm saying is that initially I have a coin 1, right? Now one of the operation is making it 2x minus 1 and the other operation is making 2x plus 1. What if I make it 2x minus 1? So if I make it 2x minus 1, it becomes 2 into 1 minus 1, that is 1 itself. So it comes back to it. So that's of no use. What if I make it 2x plus 1? If I make it 2x plus 1, this becomes 2 into 1 plus 1, that is 3, right? Now that makes sense. If I make 3 with this first operation, so this would become 2 into 3 minus 1, that is 5. If I do it with the second operation, 2 into 3 plus 1, that would become 7, right? This would become then 5 into 2 minus 1, that is 9. Second operation would give 11, this would give 13, this could give 15, so on and so forth. So what are you able to analyze from here? From here, you can simply see that there are no elements that are actually even. And I didn't even actually required to do this kind of operation to come to that conclusion, because you are having 2x minus 1 and 2x plus 1. So when you multiply any element with 2, right, 2 multiplied by x would always give you something even. And when you're adding or when you're subtracting 1 from it, your answer would have been odd. So that was obvious, right? But one more thing is that no element is missing. So you have 1, then 3, then 5, then 7. So all of the odd elements are present over here, right? So one simple thing is that you can say that if your answer is even, then it does not exist, right? What about the remaining case? So let's say your like answer is not even. Let's say I gave you 11. So how would you come up with? So the question also asks us to give the steps of the operation. Not only that minus 1 or yes or no kind of scenario is not there. So you also need to print out the operations required. How would you do that? You can see from here, it's comparatively tough to move from top to bottom, right? Because at each node, you'll not know how to go. So basically, a parent can have 2 children, right? So you have to decide that where should I go. However, a child only has a single parent. So it's always easier to go from a child to parent, because I don't have to think about it that where I should go. A child has a single parent, so he'll directly go to his parent. A parent had multiple children, so he'll have to decide that where should I go. I hope that makes sense. And then what I'll say is that since this is the scenario, so let me do one thing. Let me go from the child to the parent itself, or from the whatever value n I am having, I'll try to go to 1. That is the topmost value. But what is the kind of what is the kind of scenario I should imagine? So the thing over here is that you can say that 11 and 9 both are going to 5. So where should I apply operation 2 and where should I apply operation 1? So over here it's pretty simple that okay, you'll say that okay, operation 1 is 2x minus 1, operation 2 is 2x plus 1. So I'll apply 2x plus 1 to this. Oh sorry, not 2x plus 1, but you'll do the opposite. So your parent, okay, so your child basically is 2x plus 1, right? So this would become c, and this is a parent, right? Now if you have to go from your, okay, this is your child, right? So if you have to go in the reverse order from your child to your parent, you'll say this would become c minus 1 by 2, right? So in what all scenarios you need to do c minus 1 by 2, and in what all scenarios you need to do c plus 1 by 2. So simple trick over here is that in the scenarios wherein after doing c plus 1 by 2, you get an even number, right? Don't do that, because in the entire tree there were no even numbers itself, right? Also, if from the left child you do 2x, you do x minus 1 by 2, you'll go to the wrong place, because over here it will become 9 minus 1 by 2. That would actually be 4. They cannot be 4 anywhere. So simple trick would have been to check that if c plus 1 by 2 or c minus 1 by 2 is leading to an even number, don't do that, do the other thing, right? So I'll simply check that, okay, if c plus 1 by 2 is odd, right? If it's modulus 2 is, okay, someone's mic is not mute. Can you please mute it, bro? Whoever it is. Okay. So if this is odd, right? In that case, cool. But if it's not odd, then do the other operation. So in that case, if it's not on, then do c minus 1 by 2. So that is the entire thing that's required. But wait, after performing each of these operations, we'll definitely get that okay, over here I wanted to perform the operation 1, then 2, right? But now I actually wanted that what would be the operations if I'm going from the parent to my child, right? Or if I'm going from 1 to x or 1 to n. So just store this in a vector and then just reverse it when you're gonna print the results. So let's look at the code. Okay, this is the code for this. Okay, so initially you can check that if the number is even. If the number is even, it can't exist. We already discussed that, right? So if the number is even, then just print -1. If it's not even, then we need to make it to 1, right? So we'll keep performing the operations till the time your n is greater than 1. What we'll do is, firstly I'll check that if my n plus 1 divided by 2 is becoming an even number, that means I need to perform the other kind of operation, right? So in that case, I'll simply say that, okay, the result is 2, or I need the second kind of operation. If that's not the case, I need the first kind of operation, right? After that, I'll say that if I'm needing the first kind of operation, I basically needed to do a n minus 1, basically need to do a n plus 1 by 2, right? So I'll just add 1, or I'll say n plus plus. After that, I'll divide it by 2. So over here, I've just mentioned another statement. You can actually remove it. I don't think, yeah, you can basically remove it because it doesn't matter. Right? After that, you'll say that you wanted to print the number of steps required. So that would be in your res. And then you'll also need the result itself. So firstly, reverse it because we are initially going from parent to child, or from child to parent, but we had to go from the parent to child. So we just reverse it and print it. Any doubts so far? All good? Yeah, all good, or any doubts? Cool. Okay, so let's discuss the problem C. So the problem C is make it a permutation. So what the problem states is that you have an integer array A of length n. There are two kinds of operations that you can make. So first operation is that you can remove an integer from A. So we can remove any integer from any location, right? And this operation costs C. The other kind of operation is that you can insert an arbitrary positive integer x into any position of A, right? So these are two kind of operations you can perform. After that, what they're saying is that they'll be giving us an array what we have to do is that we have to make it a permutation. Now permutation basically means that it should contain elements from 1 to n, where n is the length of the array, right? And it's obvious that no element should repeat, or there shouldn't be any element that is in the range of 1 to n and that is empty, or that is missing from the array. So that is what we want to do. Over here the constraints are actually going up to 10 to power 5. So at max you can use an order of n log n solution. If you're using anything more than that, then it's gonna fail. Now how do we come across the solution, or how do we actually decide? So a very basic thing is that you can call it DP or you can call it greedy, but I'll just call it observations because it's not that tough. So what you want to do is that, let's say this is your array, right? So firstly, let's just sort it. Why are we sorting it? Because I just want to know that, let's say I have an element 3, right? If I have an element 3 and if I want to include it into my array, that means I have to have the elements 1 and 2 as well, right? And I can say that, okay, 3 is the last element I want in the array. So as soon as I say that, let's say I is the last element or the biggest element, right, I want in the final permutation. So that would mean all the elements from 1 to I minus 1 should also be there in the array. So if I've already sorted it, so when I'll reach the index I, I'll already know that if these elements were absent or were these present, and if they were absent, then how much cost I need additional to, how much additional cost do I need so that I can put these elements into the array, right? And also, since I'm now standing at I and I know that the size of the array is, let's say, n, right? The entire array size is n, the initial array that I had. So I'll say since I want 3 or I to be the last element, so all the elements in n minus I minus 1 needs to be deleted, right? So that becomes easy for me to do. So again, going about it. So what I'm saying is, currently standing at I would have already traversed all the elements from 1 to I minus 1, right? Since I have done that, I would know what is the cost required in order to fill up all the elements in this range, right? I'll also know, so since I know the size of the array as well, I'll know how many elements are there to its right. The elements to its right can simply be given as n minus I minus 1. And these are the number of elements I'll have to delete if I want 3 to be the biggest element in the array. So this becomes pretty simple, and this is what we need to do. And that's the reason we actually sorted it. So the only reason for sorting it was that I wanted elements to be in a flow, so that when I'm going from left to right, I'm always traversing elements that are smaller than the current element before it. So let's look at the code. Any doubts in this? I think a few people were not able to solve this. Do you have any doubts? Oh, Adarsh, yeah, sure, I'll just zoom. Give me a second. This is a D problem, but yeah, I'll zoom over here. But I hope there are no doubts. If there are, let me know. Yeah, Cheams on Tequila. Okay, cool. Others, this is fine. Is this size fine? Let me know if the size isn't fine. Cool. So what I'm doing is, as I told you, also what would be the result value initially? So I can say that, okay, I'm going to delete all the elements. Cool. If I delete all the elements, what's the cost for that? C is the cost for deleting one element. For deleting n elements, it would be C into n. Plus, since I actually want at least one element in my array, and let's say that element is 1, right? And obviously if there's only one element, it can be 1 only, right? So since and so for that I'll have to add a D. So this is my dummy value, right? I'll just compare it with the result I'll be getting sequentially in this. So initially I'm sorting it, then I'm setting my previous value and my current value. So previous initially is set to 0 because the first element I actually want is 1. Now what's the value before 1? That's 0. So in order to avoid a lot of if-else statements, I provided the value of previous to 0. And what's current? So current basically means that if you're standing at index I, how much operations or how much cost was required in order to satisfy all the elements from 0 to I minus 1, right? So over here you'll say that if your current element is equal to your previous, that basically means that you are having duplicate elements now, right? Now what you can say is that you'll say that, okay, the current element is the one that was similar to the previous element. So I'll say, okay, I'm going to keep the previous element, then definitely I have to delete this one. So if you're going to delete this particular element or the element I, it's going to cost you C. So let's increment that to cur, then you're gonna say that okay, all the elements from I from 0 to I are already covered, and the elements toward the right of it, that is n minus I minus 1, are still remaining. So let's delete all those elements. The cost for deleting all those elements would be C. So let's multiply C into this, right? And so this basically means the right part. So you're deleting the entire right part. This is the left part. So you'll say the cost for the left part plus the cost for the right part. You'll set that to rest. What's the other case? The other case could be that it's not equal to that, but it's not even 1 plus that. So it's like you are having 1, 2, that's fine. But let's say you are having 1, 2 and then 4. So basically 3 is missing. So that's the case over here. Now what if this kind of case arises? Then whatever the missing values are, for example, in case of 1, 2 and 4, the missing value was 3, right? So you'll have to add that particular value yourself. So how many numbers are actually missing? So that could be given by vi minus prep minus 1. In this case, it would have been 4 minus 2 minus 1. That would give you 1 itself. So a single element, that is 3, was missing in this case, or the sample case we took. So if this is the scenario, you'll have to add all those elements. So you'll say, okay, I'm going to add all those elements, and how much cost is going to take you to add that? It's going to take you vi minus previ minus 1 into d, right? You'll add it onto the top of that, and then you'll say that your result is minimum of whatever result you are having. Or you'll say, okay, I'm going to include whatever cost is required to cover the left part of it that is stored in cur, right? So you can see that whenever we are going from left to right, we are always keeping the cost required to construct the elements from 0 to I in the variable cur, right? Cur plus the cost required to delete all the elements to its right. After that, we'll set that, okay, we have traversed this particular element. So let's update our previous value to vi. We'll just print rest after that. Cool. So that was it for the solution. Any doubts? Okay, cool. Let's move on to the next problem. This definitely is a good problem. It's not that tough. I don't know, like what I did, probably like Abhishek was saying, I probably just took the variables wrong. I didn't initialize them properly because the height of the tree could have actually gone to 10 to power 18. I was considering it to be 10 to power 9. So that's why probably I got a wrong answer. So yeah, a lot of wrong answers. So what the problem basically means that the snails are climbing a tree, and the tree height is h meters, and the snail start at the position 0. Now each snail has two attributes, A and B. So on the first day, it will climb A, and during the daylight it climbs up, right? But during the night when it's resting, so he slides down B meters. So basically in a day he actually climbs A minus B meters, right? Now they say that if on the nth day the snail reaches the position H for the first time, then he will finish climbing and he'll stay over there. So it's not going to be the case that it already reached the top of the tree and then it again slides down. If it has reached the top, he knows that, okay, he has reached the top, right? Okay. The snail doesn't necessarily need to climb 8 meters in case, yeah. So that's obvious. So let's say you are at level 0 right now and you can climb, your A is actually 10, right? And the height of the tree was actually 5. So you only climb 5 meters. You can't just keep climbing on air itself. That's needless to say. So unfortunately, you do not know the exact tree height H at first, but you know that H is a positive integer. So the tree is not dug in the ground itself, it's erected. And there are Q events of two kinds. So what do events mean over here? So there is a type of event 1 that means that a snail with attribute AB comes and claims that he spent n days climbing the tree. If this message contradicts previous adopted informations, so before this snail, let's call this snail SI or S1, or yeah, let's just call it SI. So before SI, it's possible that some snails already came to you, right? And they gave you their information that, okay, it took this is the value of A for them, this is the value of B for them, and it took them, let's say, n days, right? So you already know this information. Now the snail is coming and this is also giving you some information. Now it's possible that it doesn't make sense. Now, why wouldn't it make sense? Now let's say you said that, okay, based on the information given by the previous snails, I was predicting that my L to R, or the height of the tree, would be somewhere in the range, let's say 10 to 12, right? Now based on the information that he's giving you, the height of the tree is coming out to be 5. Definitely doesn't make sense, right? So in that kind of a scenario, you'll have to reject this information. So you're going to believe that he's not telling you the truth, and you're going to you're gonna reject it. And there's another kind of operation. So a snail would come, it will tell you the attribute A and B. So it will say that, okay, this is the value of A I have, that is the number of steps I go up in the daylight, and this is the number of steps I slide down during the night. So with this information, do you know how much step, like how many days it's gonna take me to climb the tree? So if you can verify or like if you can give it a proper answer, you can definitely come up with a number that, okay, it's gonna take you, let's say, X days. Then you give it that number. But let's say you're not sure about it. So if you think like, okay, it can take you maybe like 5 days, or it can even take you like 2 days or 3 days. In that kind of a scenario, what you'll do is that you'll say that, okay, since we don't know the answer for this, so I'm gonna say that, okay, so since we all don't know the answer, that how much long it's gonna take you to travel from the bottom to the top, in that case, we'll just print -1. Cool. So this is what we want to do. So in the operation 1, if we are ignoring its information, we print 0. If we are accepting its information, then we are printing 1. Now the question is kind of easy. The only thing it relies on is a basic fact. So what's that fact? Now let's say a snail 1 comes, right? And snail 1 says that, okay, it takes like I go up by A, I go down by B, and it took me n days. So what does that mean? That basically means that in the n-1 day, I was not able to climb. Not able to climb, let's say. Cool. If I'm not able to climb in n-1 days, so that basically means that n-1, so what would be the maximum height it would reach in n-1 days? So the way the snail climbs it, it goes by A, it comes back by B, then it goes by A, then it comes back by B, it goes by A, then it comes back by B, right? This is how the snail travels. Okay, so this is actually the height, right? This is the tree. Okay, this is the tree. Anyway, so we can say that in n-1 days, you would have covered, in the daytime itself, you would have covered n-1 into A minus n-2 into B distance. That makes sense, right? So if this particular value, in this particular value, you are not able to climb the tree. So this value is definitely smaller than the height of the tree. But you were able to climb it on the nth day. So what is the height you actually attained on the nth day? That was n into A, right? Plus n-1 into B. Right. So you'll say this particular value is either greater than or equal to the height of the tree. So let's call it L. Let's call this R, right? So we don't know the height of the tree yet. So we'll say that the height of the tree is greater than this, right? And it's less than or equal to R. Why is it greater than this? Because up till this time, it was not able to climb the top, right? So this the height is definitely greater than it. It could be that it's just greater by a single unit, but it is greater by some positive integer. So this is the fact. Now what we'll do is that, so this is the type 1 operations, right? That you get. Yeah, this is the type 1 operation where you're using the fact that, okay, it took you n days or not. The type 2 operation is that a snail comes, it gives you the values A and B, right? And then it asks you that how much long it's gonna take you. So you're gonna say that, okay, I know that the height actually ranges from L plus 1 to R, right? I'll calculate the value for both of this. So I'll calculate the value for L plus 1, I'll calculate the value of R, right? And then I'll check if the values are same. So if it's, I can say that, okay, this is the minimum height. So L plus 1 basically is the minimum height you're thinking it to be. And R is basically the maximum height it can have, right? If your AB, okay, so yeah, minimum height and the maximum height, if you're able to, if both of these values, so keeping L plus 1 as the height, let's say you say with the constraints A and B, you need maybe F days, cool. And keeping R as the height, let's say it comes out to be that you need G days, cool, with the constraints A and B, that you travel A units up and B units down in a day. Now, if these two values are equal, only then I can tell with a guarantee that, okay, it's going to take you F days or it's going to take you G days. If it's equal, it doesn't make any difference, right? But if these values are not equal, so it could be that f is less than g, right? If f is less than g, in that case I'll not be able to tell you with certainty. It could take you f days, it could take you f plus 1 days, or it could take you all the way to g days, right? So if this kind of a scenario exists, in that case I'll not have any kind of certainty. I'll say -1, or that I cannot give you the values, right? If this is fine, then I'll say that number of days required. Also, when would we discard the information of a particular snail? So that would happen. Let's say your L is set to 8 maybe. Cool. So I'm just giving an example 8. Now the current snail comes and it tells you that your L is actually 10. Right. So what does L means? That initially it was we were having the opinion that in 8 days you cannot climb to the top. Right. Okay, give me a second. Okay, so not okay, so this was the previous one. Let me draw that again. So yeah, this was the previous one, previous information that you had. So the previous information that you had was that L is 10, let's say. Cool. So that means basically in 10 days you cannot climb. And then the R you were having, that is the upper limit for the tree. So let's say that a limit was maybe like 20. Now a new snail came, and according to its information, the upper limit or the upper height of the tree is, let's say, 9. Right? Now you'll say that, okay, I already know that you cannot climb the tree in 10 days, right? And you are saying that you're going to climb the tree in 9 days. Not 10 days, sorry. You cannot climb the tree. The tree is actually more than 10, right? From L is equal to 10, we know that the tree is actually more than 10. And by 9, it means that the tree is less than 9, right? So this doesn't make any sense. This definitely doesn't make any sense. If you already know that the tree's height is greater than 10, and if I'm telling you that tree's height is less than 9, these are two contradictory things. If such kind of a situation arises, then you just ignore that information. Else you update the information. The way you're gonna update your information is that you'll say that your L, that is the lower limit of the tree, is gonna be max of the previous L you're having and the current L it gave you. However, the R or the upper limit for the tree, if you are considering this particular information and you're not considering that this particular information is false, then your R is gonna be minimum of previous of R or the current R. This makes sense? We'll walk through the code. Any doubts over here? Cool. Let me walk you through the code. Okay. So yeah, definitely not my code. I don't use scanf and printf. I just copy this code so that I can have this session pretty quick. And yeah, so what we are doing is we are firstly taking Q, that is the number of queries, right? After that, we are taking L and R. Now, probably the reason I messed up is that I was taking L as 0 and R as 1 in 9. Now, the tricky thing was that they were not saying that the tree's height is limited to 1 in 9 or 10 to the power 9. They were just saying that your AB values, AB is less than equal to 10 to the power 9. But it could be the case that A is equal to, let's say, 10 to the power 9, right? Okay, 10 to the power 9. Okay, I'm missing it. Anyway, 10 to the power 9. And let's say your N was also 10 to the power 9. And your B was, let's say, 1. In this case, from this information, you'll get to know that, okay, the height of the tree is somewhere around 10 to the power 18, right? So I was initializing it wrong. That's why it took me so long in the contest and I couldn't even do it. Cool. After that, you'll say if it's the operation 1, then you're supposed to take three units or 3 informations from the snail, that is A, B and N. You'll take these 3 informations. Then you'll say that what is the lower limit that you are having, right? So we already discussed that in N minus 2 into A minus B, you can say, right? Or it's similar to saying that N minus 2 into A plus N minus 1 into B, right? You're not able to travel, reach, this definitely is not the height of the tree, right? Because you already tried this much and you still not were able to reach the top. So the minimum height that could be there is +1, right? This definitely is not the height. The height has to be greater than this. So the lower limit is +1. Now what about the upper limit? So upper limit is basically that on the nth day you are able to reach the top. So you'll say n minus 1 into a minus b plus a. That is similar to saying n into a plus n minus 1 into b, right? And then you'll say that if your n is 1. Now n is 1 is actually a special case. Now why is it so? N is 1, n equal to 1 is a special case because the snail is saying that I reached the top in just a single go, right? Or in just a single day. So we have no clue about what the lower limit is. So let's say the snail says that, okay, I can go up 1000 units in a day, and I reached it on the in a single day itself. So the height of the tree could be any end outs. Okay. So if it says such a thing, then the height of the tree could be anywhere from 0 to 1000, right? So this definitely becomes a special case. So we'll set, if this is the case, then QL is equal to 1, or the minimum height of the tree is 1. So it cannot be 0. Height is always positive, as I said. And then QR is equal to A. Right? In a single day, you are able to reach the top. Now we'll say that if your current limit that you are computing, or the lowest height of the tree that you are computing right now, if it's greater than R, then also the answer does not exist, and this snail is probably drunk and it's giving us wrong values. Or if your QR is less than L, even then it doesn't make sense, right? Because if this happens, then basically your L to R would become invalid, because you are saying that, okay, your L is max of L and current L, right? And your R is min of R and QR, right? Now this kind of a scenario happens if you assign these values. So your segment only makes sense if L is less than equal to R, right? But if this kind of a scenario is happening, right, where QL is greater than R or QR is less than L, that basically means your segment was becoming somewhere like L is greater than R. So your left limit was greater than the right limit, or the lower limit was greater than the upper limit, wherein it doesn't actually make sense, right? If that's the case, just print 0. Else, if that's not the case, then you have the answer, right? So update the values and return a 1. After that, what's the second scenario? So the second scenario is that the snail wants to know that how much time it's going to take it, right? So you'll say that, okay, considering the lower limit that we know, so we know that the lower limit is L. So for the lower limit, it's going to take you this much time. We're doing nothing special over here. We're just dividing it by a minus b. That is the number of days it takes, right? And over here, so the difference is, over here we are taking L, that is the lower limit, and over here we are taking R, right? So it's going to take you this much time or this much time. Cool. Okay, we have to select, like we have to take the maximum with 1L, because it's possible that your answer 1 actually becomes 0. So that definitely is not a valid scenario, because your answer has to be greater than or equal to 1. In 0 days, you cannot go anywhere. So that's why we are taking maximum with 1, right? So we'll say whatever the maximum value you're getting for the, like whatever values you're getting, just take those. So you'll be having answer 1 and answer 2. Now you can only precisely tell your answer if they're equal. So if these are equal, then tell your answer, else print a -1. So yeah, that is the working code for this. I hope you understood this. So it's failing because the test case is not valid. I was just testing it. Yep, it got accepted. So cool. Any doubts in this? If you have some other kinds of doubt, like you want to show you solution, so I'm going to just stop the recording and then you can ask those doubts. Give me a second.